Hello again, Math 10Cs. In today's lesson, we're going to look at a different form of an equation we can use to write a straight line. Up until this point, what we've done is we've been writing the equation of a straight line using what we refer to as the slope-intercept form. So we can just quickly summarize this here. And the slope-intercept form of equation is always written in the form y is equal to mx plus b. The usefulness of this equation is that it's presented in a way that tells you the slope, because the value of m is your slope. And it also tells you what the value of b is, and b specifically is your y-intercept. When equations are written in this format, y equals mx plus b, it's actually like really easy to plot the line on a graph by hand without using technology, because the easiest way to do it would just be to plot the y-intercept and then construct a slope triangle from the y-intercept to figure out a second point, and then you just kind of you draw a line that connects the 2 points together. But we'll do a bit more practice of that later in the unit, where we're going to continue to work on drawing lines by hand without the use of the calculator. Now, we have another way we can express an equation for a straight line. This is referred to as the general form of an equation. Now, what the general form of an equation has is, if you were to take your y equals mx plus b equation, and if you collected all of your terms onto a single side of the equation, you'd have like all these terms on one side. So what you'd have on one side is you'd have like your term with the x variable, your term with the y variable, and you'd have your constant. And then on the opposite side of the equation, you'd have nothing. So that would just be equal to 0. So that's what your general form is. Your general form is when you take all the terms that make up an equation for a straight line, and you just collect them on one side of the equation. Now, a couple notes about this. When we write down this equation, so ax plus by plus c, what we want is we want our coefficients to be integers. This is a little bit different compared to the y equals mx plus b format, because we could have had an equation in the y equals mx plus b format that might have been an equation like y is equal to -3 over 4, x plus maybe like 7 over 2. In which case the coefficient attached to the x is a fraction, it's -3 over 4, and the y-intercept is also a fraction, 7 over 2. However, for this form, the form ax plus by plus c, we want the numbers in front of x and y and the constant to always be integers. And the other thing about this equation is that when we're trying to decide like which side of the equation should I collect the terms onto, it's customary for the value of a in the equation to be a positive number. So whatever the x term is, we want the x term to be positive. We don't want to have a negative sign in front of that. Okay, so let's illustrate how we would do this. So the first example says we're starting off with an equation in the form y equals mx plus b, and I'm going to convert that to the general form of the equation. Okay, so this first one, y equals 5x minus 8. Now, what I want to do is I want to collect all the terms onto the same side of the equation. Now, if you look here, the x term is positive, so we're going to leave that x term on this side of the equation. So what I'm going to do is I'm going to subtract y from both sides of the equation to get them on the same, get everything on the same side. So I'll subtract y, and then we could write down, as we could say 0 is equal to 5x. Now we could write 5x minus 8 minus y, but it's more customary just to write it in the order of the x term, then the y term, then the constant term. So I'm going to write down 5x minus y minus 8 would be equal to 0. And that's my general form of this equation. okay? Everything is collected on the same side of the equation, and the coefficients attached to the x, y, and the constant are all integers, and the x term is a positive. Now this gets a little bit tougher here. So now we have y is equal to 2 over 3x plus 7. So the immediate problem here is, well, you could just be like, how do I get it into general form? Well, subtract y from both sides of the equation. But that'd be a problem because you have a fraction in front of the x term. So the first thing you want to do is you want to get rid of that fraction. And here's how we do this, okay, to get rid of the fraction. So I'll write a little note up here of how to do it. So I'm going to say, to get rid of fractions, what you want to do is you want to multiply the entire equation by the lowest common denominator of the fractions. Now for this equation that we're starting with right here, there's only a single fraction. So if you had a single fraction, the lowest common denominator would just be this value 3 here. So what I'm going to do is I'm going to put the entire equation in a set of brackets. And then what I'm going to do is I'm going to multiply this entire equation by the lowest common denominator, which is a 3. So I'm going to go 3 multiply by, so this is a multiplication operator, not an x symbol. I'm going to multiply by every term in the equation. Now to do that, you need to take the 3 and apply the distributive properties. This 3 would multiply by the y, this 3 would multiply by the 2 over 3x, and this 3 would also multiply by the 7. So if we expand this out, 3 times y would be 3y, and then 3 times, we'll just write it right beside this fraction here. So we're going to go 3 multiplied by 2 over 3x, and then plus, we're going to multiply this 3 by the 7, so 3 times 7. Now here's what happens. If you look at the fraction here, okay, so we're going 3 times 2 over 3, you have a 3 on the top and a 3 on the bottom. So these 3's would actually just cancel each other off. So that's why we multiplied the entire equation by the denominator. So it's a way of getting rid of the denominator. Okay, now we need to expand things out. So this side would be 3y, would then be equal to, now you're just left with a 2x here. So 2x plus, and then 3 times 7 would be 21. Okay, now for the general form, we want to collect everything on the same side of the equation. So what I'm going to do here is the x term is positive, so we're going to leave the x term on this side, and then we're going to subtract 3y from both sides of the equation. So I'll subtract 3y, and I'm going to subtract 3y. Okay, so when I do this, you would then get 0 would be equal to 2x. So write your x term first, then your y term, which would be minus 3y, and then the constant term, which would then be plus 21. Okay, so that's my general form. Your general form has everything on the same side of the equation. The coefficients in front of the variables or attached to the variables are integers, and so is the constant. It's also an integer. Okay, next one. This is a little bit tougher. So this one actually has 2 fractions as opposed to 1 fraction. So here's where I'm going to have to use my rule. So I said to get rid of fractions, multiply the entire equation by the lowest common denominator of the fractions. Now, the lowest common denominator of the fractions would just be the lowest common multiple of these 2 denominators. Now, I suspect most people can immediately identify what the lowest common multiple is, but if you ever forget how to do that, you could write down a multiple list. So you have like 4, you have 5, and we'll write down a few multiples. So we've got like 4, 8, 12, 16, and then 20. And then we have 5, 10, 15, 20, and then 25. So the lowest common multiple would be the number that's common in the two lists, and it's the lowest number. So if you look at the list here, that would be a lowest common multiple of 20. Okay, the 20 right here is the lowest common multiple. Now, to get rid of these two fractions, I'm going to first of all put the equation in brackets, and then I'm going to multiply this entire equation by 20. Okay, so we're going to go 20 multiplied by this entire equation. And once again, to multiply it correctly, you apply the distributive property. So this 20 is going to get multiplied by the y. It's going to get multiplied by the -1 for x. And it's also going to get multiplied by that term. So let's see what this would look like if we do it. Okay, so 20 times y would just be 20y. This would be equal to, okay, let's write this multiplication beside the fraction. So this would be 20 multiplied by -1 over 4 x. And then we're going to go plus 20 multiplied by 3 over 5. Ooh, just barely fit that in there. Okay. Just put some curves on that x there so it looks more like an x as opposed to a multiplication symbol. Okay, so we're going to reduce these fractions a bit here. So if I look at this, in this fraction, 20 divided by 4 would actually reduce to a fraction that is 5 over 1. And for this fraction, 20 divided by 5 would reduce to a fraction that's 4 over 1. Okay, so let's expand this out now. So we then have 20y would be equal to, okay, so here you'd have 5 times -1 divided by 1. So that would just be -5. So this would turn into -5x. And then here you'd have 4 times 3, which is 12, divided by 1 would just be 12. So that'd be -5x plus 12. Now, you'll notice here that the x term is negative, and we don't want the x term to be negative. So instead of moving the y term over to the right-hand side, we're actually going to move the x term over to the other side because we want it to be positive. So I'm going to add 5x to this side. And then when you do to one side, you got to do to the other. Add 5x. And then we're also going to take this constant term and move it to the other side as well. So we're going to subtract 12. And then we're going to subtract 12 here. Okay, so this would then turn into, on the left-hand side, again, you write in the order x, y constant. So you have 5x plus 20y, subtract 12, would be equal to 0. And that is my equation in general form. Okay, so let's go down here. Now, the second example is we're going to do the reverse process. So the first example is we started in the slope-intercept form, so the y equals mx plus b form, and we turned it into the general form. And now for the second example, everything's in the general form, and we want to turn it into y equals mx plus b form, because then that's going to allow us to determine the slope and determine the y-intercept. The general equation, the way it's presented, does not really tell you what the slope or the y-intercept is. So we need to convert it into a form that's going to be useful. Okay, so we're going to turn these equations into the form y equals mx plus b. The way to do that is all you have to do is just isolate for a y. Okay, so we can get the equation isolated for a y, then we will turn it into y equals mx plus b. Okay, so let's start with this first one. We have 2x minus 5y plus 25. Now, I want to get the 5y by itself, but there's one problem to start off with. Like there's a negative term in front of the 5y. So what I'm going to do is generally when I want to solve for a variable, it's best to solve for the variable if it's a positive term. So I'm actually going to start off just by adding 5y to both sides of the equation. So add 5y, add 5y. Okay, so then this would look like 2x plus 25 would be equal to 5 times y. Now, to get y by itself, I'm just going to divide both sides of the equation by this 5 here. So we're going to divide by 5, and we're going to divide everything on this side by a 5. Okay, so this is going to get rid of the 5s here, so we can just cross those off. And then, okay, I'm gonna flip things around. I'm gonna write the y term on the left-hand side, and I'm gonna write this side of the equation on the right-hand side. Usually when you're isolating for a variable, you want the variable you're isolating for to be on the left-hand side. So this is gonna be y is equal to, okay, now you gotta figure out how to deal with this fraction here. So the way to deal with it is, we're gonna write two separate fractions. And the way I get the first fraction is you take this first term and divide by this denominator. Okay, so the first term divided by the denominator would then be just simply 2x over 5. And then the second term would be, you're going to take the second fraction is going to be, you're going to take the second term and you're going to divide by the exact same denominator. So we're going to divide 25 by 5. So this would be 25 over 5. And then let's try to reduce this. So this would turn into y is equal to, the fraction 2 over 5 doesn't reduce, so we're going to keep that one as 2 over 5x. But 25 divided by 5, that divides evenly, so that would just be plus 5. Okay, now we can easily identify the slope in the y-intercept. So y equals mx plus b. Well, the slope is the value of m, so that'd be m is equal to 2 over 5. That's the first part of my answer here. And then the y-intercept, b, would just be equal to 5. Next one, you have 6x plus 2y minus 15 equals 0. Now this time around, the y term is a positive. So we're actually going to leave the y term on this side of the equation. So what I'm going to do is I'm going to get rid of the 6x, and I'm going to get rid of the negative 15. So to get rid of the 6x, we're going to subtract 6x from both sides of the equation. Subtract 6x. And to get rid of the negative 15, we're going to add 15 to both sides of the equation. So then this would give me 2y. Actually, I'm going to write the y a bit differently. Okay, so we have 2y would then be equal to negative 6x plus 15. Now, to get y isolated, just divide both sides of the equation by 2. So we'll divide that side by 2, divide this side by 2. So the 2's on this side would just cancel off. And then we need to write down the two fractions on this side. So again, the way you do that is you're going to take the first term, which is negative 6x, and divide by the denominator. So then that would give me negative 6x over 2. And then we're going to look at the second fraction is going to be take the second term and then divide by that exact same denominator. So that's going to be 15 over 2. So in here, you then have plus 15 over 2. Let's see if we can reduce this fraction. So any of these are fractions. So negative 6 over 2 would turn into negative 3. So you'd have negative 3x. And then 15 over 2. Well, that fraction does not reduce. It would just be left as 15 over 2. Okay, so now we have it in the form y equals negative 3x plus 15 over 2. So the term beside the x is the slope. So that's going to be m is equal to negative 3. And then the constant term is going to be the y-intercept of the graph. the y-intercept of the graph, is going to be 15 divided by 2. Okay, so that's the unfortunate thing with the general equation. The general equation is not very useful in identifying what the slope and the y-intercept is. So you would need to actually take that equation and turn it into y equals mx plus b to determine that. Okay, next one here. It says we have the lines 3x plus 8, 3x minus 4y plus 8 equals 0, and 5x minus ky minus 6 equals 0. Okay, so there's an unknown value of k in that equation. And what it tells me here is that both equations have the exact same y-intercept. Okay, and what we want to do is figure out what the value of k is. So here's how I'm going to do this. Okay, first of all, I'm just going to call this guy line 1. So I'll say L1. And I'm going to call this one line number 2. Now, what the problem's telling me is that line 1 and line 2 have the exact same y-intercept. So one way you could do this problem is you could take both of those equations and you could turn it into y equals mx plus b format. And then you could identify the two y-intercepts, set them equal to each other, and then calculate the value of k. But there is actually a strength of the general equation. So the general equation is actually pretty good at being used to identify the intercepts of the graph. So if I want to know the x or the y-intercepts of these two lines here, these equations are actually set up in general form to do that quite easily. Okay, so let's try to figure this out. So what does it mean to calculate the y-intercept? So the y-intercept on a graph is when your value of x is equal to 0. Okay, so let's start off with line 1. Let's try to figure out what the y-intercept is. So line 1 is 3x minus 4y plus 8 equals 0. Okay, now I want to calculate the y-intercept. So the y-intercept would be the value of y when x is equal to 0. So what I'm going to do is in this equation, because x is 0, then 3 times x would also be 0. So this entire term here can just go away. We don't need to worry about the 3x term anymore. Okay, now this is going to leave me with, you'd have negative 4y plus 8 is equal to 0. And we need to figure out what the value of y is, and that'll be my y-intercept. Okay, so we're just solving a linear equation here. So I'm going to subtract 8 from both sides to isolate the negative 4y term. Okay, so we'll just we'll subtract 8. So that's going to leave me with negative 4y would be equal to negative 8. And then to solve for a y, just divide both sides of the equation by negative 4. Divide by negative 4. The two negative 4s will cancel off. And that's going to tell you the y-intercept of this graph is going to be equal to 2. So we'll say y is equal to 2. And I'm going to highlight this in red because we're going to make use of this a little bit later on the problem. Okay, so that's the y-intercept of the first graph. Now let's do the same thing for the second line. So for line 2, let's try to figure out what the y-intercept is. Okay, so the second line has a general form equation of 5x minus ky minus 6 is equal to 0. And again, when we're finding the y-intercept, it's the value of y when x is equal to 0. So in this equation, if x is 0, then 5 times x is 0, which means I can just get rid of this term. Okay, so this is now going to leave me with, I would then have negative ky minus 6 is equal to 0. K is just some number we're going to try to figure out the value of. Now we can still solve this linear equation just like we did over here. So I'm going to isolate the negative ky term first by adding 6 to both sides of the equation. So if you add 6 to both sides of the equation, you'd then have negative ky would be equal to positive 6. To get y by itself, just divide both sides of the equation by negative k. Divide by negative k. And then this would tell you that y, the y-intercept on the second graph is 6 over negative k. Or I'm just going to move the negative up to the top here. So we'll just say y, instead of 6 over negative k, I'm going to say y is equal to negative 6 over k. And I'm also going to box this equation. Now, what the problem tells me is it says the y-intercept of both of these graphs is the same. So what I'm going to do is I'm going to take these two equations and set them equal to each other because the values of the y-intercepts off the two lines are identical. So I'm going to say here y is equal to y. So the y-intercept of the first line is 2. The y-intercept of the second line would be negative 6 over k. Now, I want to get k isolated, so I'm going to use some cross multiplication to do that. So the way I'm going to do it here is you can't isolate for a variable that's in the denominator. It must be in the numerator. So I'm going to take the value of k, and I'm just going to have them switch spots with the 2. So then what that would tell me is that k would be equal to negative 6 divided by 2, and then negative 6 divided by 2 would just be negative 3. Okay, and this makes sense. So it says these two lines have the same y-intercept. Well, we could confirm that. Okay, so the y-intercept of line 1 is 2, and the y-intercept of line, the second line is negative 6 over k. Negative 6 divided by negative 3 would then be equal to the same y-intercept of 2. So that does match up correctly. Okay, this is going to start to get a little bit more complicated. Okay, so now it says, which of the following lines is or are perpendicular to the line 4x minus 2y plus 9 is equal to 0? Okay, I'm going to call this line, I'll say that's line number 1. Now, if we think back to the previous unit in terms of what it means for like different line segments to be perpendicular to each other, line segments that are perpendicular to each other have slopes that if you multiply them together would be equal to negative 1. Or the other way to think about it is if two lines are perpendicular, their slopes are the negative reciprocal of one another. So what I'm going to do is let's first of all figure out what is the slope of this line and then identify what a perpendicular slope would be. Okay, so let's do this up here because I'm going to run out of space if I don't do that. Okay, so let's start off with the first line. So this is line 1. So we have 4x minus 2y plus 9 is equal to 0. Now, to get the slope, you want to turn it into y equals mx plus b format. The general equation or the general form does not tell you what the slope is. Okay, so let's try to get y isolated. Okay, first thing you should notice is that the term y is a negative term. It's best to isolate for variables if it's positive. So I'm going to take this y, 2y, and then add it to both sides of the equation. So add 2y, add 2y. So this would then give me 4x plus 9 would then be equal to 2 times y. Okay, we want to get y by itself, so we're going to divide both sides of the equation by 2. Divide by 2. The 2's cancel off. Okay, I'm going to flip things around. I'm going to move the y onto the left-hand side. So again, it's customary to, when isolating for a variable, put on the left. And let's write down the two fractions now. So the first fraction would be 4x divided by 2. So again, the first term divided by that denominator. And then the second fraction would just be the second term divided by that same denominator, which would be 9 over 2. Let's see if we can reduce this. So 4 over 2, that divides evenly. So that's going to be y is equal to 2x plus, and the fraction 9 over 2 does not reduce. So we're just going to leave it as 9 over 2. Okay, now the slope of this line, because it's in y equals mx plus b format, the slope would just be equal to 2. Now, if a line or a line segment is perpendicular to line 1, then it's going to have a perpendicular slope. That would be the negative reciprocal. So that's the perpendicular sign, and just two lines with a square in it. Okay, so the perpendicular slope to this line would then be the negative reciprocal. Now, if you have like a number like 2, that's the same thing as writing like 2 over 1. Therefore, the reciprocal of that would be 1 over 2, and the negative reciprocal would be 1/2. So what we want to test here is we want to see, do all of these lines have slopes that would be negative 1/2? If they do, then they're perpendicular to this line 1. Okay, so let's test this. Okay, I'm just going to break this into a bunch of different columns here. Okay, so start with this one. So to get the slope, we have to put in y equals mx plus b format. So the way I'm going to do that is, let's get y isolated. It's positive, so we're going to leave it here. So we're going to subtract 6x, and then get rid of that negative 1 by adding 1, add 1, and then I would have 3y would be equal to negative 6x plus 1. To get y isolated, divide both sides of the equation by 3, divide by 3. So that'll get rid of the 3's on this side, and then you'd have y is equal to, the first fraction would be negative 6x over 3, plus the second fraction would be that term divided by the denominator, 1/3. If we simplify this equation, negative 6 divided by 3 is negative 2x plus 1 over 3. Okay, so this is in y equals mx plus b format. So the slope of this line would then be equal to negative 2. So now is it perpendicular? Well, the slope of line 1 is 2. A perpendicular slope to a slope would be negative 1/2. This guy's not negative 1/2, okay? It's negative 2. So this slope, negative 2, is not the negative reciprocal of positive 2. Negative 1/2 is. Okay, let's test the second equation now. So we have x plus 2y minus 12 equals 0. The y term's positive, so we're going to subtract x from both sides to get the y by itself. And then we're going to add 12 to both sides of the equation to get the y isolated, or the 2y term isolated first. So then I'd have 2y is equal to negative x plus 12. Get rid of this 2. So we're going to divide by 2 on this side, divide by 2 on that side. So the 2's cancel. And then I'd have y would be equal to, okay, so this fraction, negative x is the same thing as having a negative 1 in front of it. So this would actually turn into negative 1 over 2x. And then plus the second fraction would be 12 over 2. So if you simplify the equation, this would be y is equal to negative 1/2 x plus 12 over 2 is 6. What's the slope here? The slope is negative 1/2. So is this slope, negative 1/2, the negative reciprocal of a slope of 2? Yes, it is. Okay, we identified a perpendicular slope would have a slope of negative 1/2. So this guy is perpendicular. Let's write a little check mark here. Okay, this next one, we're going to, again, same thing. We want to get y by itself. So I'm going to subtract 5x, and then this is going to turn into 10y would be equal to negative 5x. Get y by itself, dividing by both sides of the equation by 10, by 10. Okay, 10's cancel off. And then you'd have y is equal to negative 5 over 10x. This fraction 5 over 10 can reduce, because if you divide both the top and the bottom by 5, this would turn into negative 1/2 x. Now, I should point out that even though it doesn't look like it, this actually is in the form y equals mx plus b. It's just that the y-intercept is nothing. There is no b term. Therefore, the graph would, the y-intercept of the graph would be at the origin. Okay, so the slope here would just be m is equal to -1/2. And let's check. Is this slope the negative reciprocal of the line that we started off with? Yes, it is, because the negative reciprocal of perpendicular slope would be -1/2. So this guy is perpendicular. Okay, let's jump down to example number 5. So it says, write the equation of a line that is perpendicular to 2x plus 5y minus 7, and it has the same y-intercept as a different line. Okay, so there's actually 3 lines we're going to look at here. First of all, it says write the equation of a line. So we're going to call that line line 1. And then it says this line must be perpendicular to this one. Whoops. Okay, perpendicular to this one. So we're going to call that line 2. And then it needs to have the same y-intercept as this one. So we're going to call this one line number 3. Okay, so the general idea is this. So if I want to get the equation of line 1, okay, the equation of line 1 would be y is equal to mx plus b. So to get the equation of this line, I need to know what m is, and I need to know what the y-intercept is. Now, it tells me this line is perpendicular to 2x plus 5y minus 7 equals 0. So we're going to start off by, we're going to start off by taking line 2, and we're going to calculate its slope, and then its perpendicular slope would actually be the slope of this line right here. Okay, so let's start off with that. So we'll start off with line 2. Actually, I'm going to do it a little more to the left, just if I'm going to run out of space otherwise. Okay, so we got line 2, and let's figure out its slope. So we have 2x plus 5y minus 7 is equal to 0. Okay, to get the slope, we have to put it into the slope-intercept form. So we're going to subtract 2x from both sides because the y term is positive. And then we're going to add 7 to both sides of the equation. And then I'm going to get 5y would be equal to negative 2x plus 7. Okay, to get y by itself, divide this side by 5. Divide this side by 5. Okay, so the 5s will cancel off. And then we'd have y is going to be equal to, okay, let's write these fractions out. So it'd be negative 2x over 5 plus 7 over 5. Okay, so y equals mx plus b. So the slope of this line is negative 2 over 5. But what it says is write the equation of a line L1 that is perpendicular to this line. So what we want to know is we want to know what is the perpendicular slope. So the perpendicular slope, m perpendicular, would just be the negative reciprocal. So the negative reciprocal would be, well, the negative of a negative turns into a positive, and then just flip the numerator and the denominator. So this would be 5 over 2. Therefore, now we know our first piece of information about line 1. We know that this slope is going to be 5 over 2. Okay, now let's deal with the next line. So that's line 3. Now it tells me my line 1 has a y-intercept that is the same as the y-intercept of this graph. Okay, so let's try to figure out what the y-intercept is going to be equal to. Now, there's 2 ways you could do this. You could take the equation and turn it into y equals mx plus b form, and the value of b be the y-intercept. Or the other way is, again, the general form of the equation is set up to calculate the intercepts pretty easily. So we know that the y-intercept is when the value of x is equal to 0. Okay, so then my equation would be 2x plus y minus 6 is equal to 0. And The value of the y-intercept is the value of y when x is nothing. So if x is 0, then 2 times x would also be 0. So then, you can write this out. We'd have y minus 6 equals 0. Solve for y. So you add 6, and then you'd have the value of y, which is the y-intercept, so the value of b, and that would just be equal to positive 6. Therefore, over here, we can now fill that in. So now we know that the y-intercept of my line 1 is the same y-intercept of this one, which is going to be equal to 6. Okay, now it says write the equation in two forms. Write it in the slope y-intercept form and also write it in the general form. Okay, well, we've already got it set up to write it in the slope y-intercept form. So this would just be, so now we're back to line 1. Okay, so line 1 would have an equation that's y is equal to mx plus b, but the value of m is 5 over 2 times x, and the value of b would just be 6. Okay, so that is my equation in slope-intercept form. Now, it also wants me to write it in the general form. Okay, so let's go back to this equation. Let's write it out again. So say y is equal to 5 over 2x plus 6. Now, to get it in the general form, we got to get rid of that fraction. Okay, so I'm going to take the entire equation and I'm going to put it in brackets. To get rid of that denominator, you got to multiply the entire equation by the lowest common denominator, which is just 2 here because there is only one fraction. So we're going to multiply this entire fraction by 2. And again, use distributive properties. This 2 is going to get multiplied by this, by that, and also by this. Again, that's an operator, that's a multiplication sign, not an x symbol. Okay, so let's multiply it out. 2 times y would be 2y. 2 multiplied by 5 over 2 x, we'll simplify that in a second, plus 2 times 6. Okay, so what cancels here? The 2 on the top and the 2 on the bottom. So now we've gotten rid of the fraction. Okay, so then we would have 2y is equal to 5x plus 12. General form is let's get everything on the same side of the equation. And I want the x term to be positive. So we're going to subtract 2y. And then I would have your general equation to be 5x minus 2y plus 12 would be equal to 0. Again, you always write it in the form, go the x term, the y term, the constant term, and then that would be equal to 0. Okay, final example. It says a student made the following statements about a line with an equation 2y equals 5x plus 12. We're going to call this line number 1. So we'll say L1. Okay, so it says, first of all, statement 1. The line has a slope of 5. Okay, well, let's figure that out. So to identify if it has a slope of 5 or not, we need to turn it into y equals mx plus b format. Now, this is close. It's close to being into y equals mx plus b format, except when you're in y equals mx plus b format, the only number in front of the y can be a 1. So we just have to get rid of that 2 there. Okay, so for line 1, start off with y, or 2y, is equal to 5x plus 12. And then to get y by itself, divide 2, cancel off those 2's, and you'd have y would be equal to 5x over 2 plus 12 over 2. Those are my two fractions. And let's simplify this. This is then turned into y is equal to 5x over 2 plus 6. Okay, y equals mx plus b. Your slope is 5 over 2. Okay, so the statement 1 said the line is a slope of 5. That's wrong. So the error the student made here is they didn't divide both sides of the equation by 2. Because you divide by 2, then you isolate for y, and then it's y equals mx plus b format. So that's wrong. Which immediately tells you that A and B are incorrect on this multiple choice question. Now, statement 2 says the line is parallel to 10x minus 4y plus 13. Okay, we're going to call that line number 2. Now, what does it mean for two lines to be parallel to each other? Well, two lines that are parallel would always be the same distance apart, and the only way they can be the same distance apart is if they had the exact same slope. So what we want to do here is we're going to try to calculate the slope of this line and see if it's the same slope as line number 1. Okay, and that'll tell us if it's parallel or not. Okay, so line 2 has an equation that is 10x minus 4y plus 13 is equal to 0. And then we're going to get the, okay, so we want to get the y term by itself. Now, the y term's negative here, so we're going to move that to the other side of the equation. So we're going to add 4y. And then what I would have is I would have 4y. Actually, let's write it like this. Let's do 10x plus 13 would be equal to 4y. Get the y by itself, so divide by 4. Divide by 4. The 4's cancel. And then you would have y would be equal to, let's write our fractions out. So this would be 10x over 4 plus, take that second term, divide by the same denominator, 13 over 4. And then let's see if we can reduce this. So the fraction 10 over 4, if you divide both the top and bottom by 2, would reduce to 5 over 2 x, and then plus 13 over 4. Okay, so the slope is 5 over 2. So what I can see here is the slope of line 1 is 5 over 2. The slope of line 2 is 5 over 2. So I can say since the slope of L1 is equal to the slope of L2, they are parallel. Okay, so statement 2 is correct. Now, statement 3, this is a little bit different. So it says the line passes through the point -2, 1. Okay, so again, in an ordered pairs always go x and then y. Now, here's how I'm going to do this. Okay, so first of all, I'm going to take my line. So my line is for line 1. Let's write down the equation in the y-intercept form. So we have y would be equal to slope-intercept form, 5 over 2x plus 6. Now, what I'm going to do is I'm going to take the value of x, I'm going to plug it into the equation, and then see if I can get the value of y, which would be 1. Okay, so here's I'll write it out. So I'll say sub x equals -2 and see if y is equal to, I think it was 1 here. Okay, that'll prove if this point is on the line, okay? So if I evaluate this equation for when x equals -2, it's telling me that the ordered pair should be -2, 1. So we're just going to sub this in and see what happens. Okay, so I'm going to plug in x equals -2 into this equation, and we're going to evaluate the equation and see if we can actually get a value of y that's 1. So I'd have y would be equal to 5 over 2 multiply by -2, and then we're going to add 6. This would be equal to 5 times -2 is -10, divided by 2 plus 6. And then -2 divided by 10 would be -5 plus 6. And then -5 plus 6 is equal to +1. Okay, so this is correct. So the question was, does the line pass through the point -2, 1? Or another way you could think about it is this point on the line? And the way we can test that is basically by taking the x coordinate, plug it into the equation, which we did here, and then see after I evaluate the equation if x equals -2, if I can get that y coordinate. And if I do, then it means that that point is on the line, or the line passes through that point. Okay, so therefore, that means that statement number 3 is correct, which means that C is the correct answer here. All right, so that is it for this lesson. And you can practice this general form equation by completing numbers 1 through 6.